A few summers ago, I built my own custom 3D printed electrospinner, and recently I've been wanting to electrospin again, but I've since dismantled my old electrospinner. So I've been needing to build another one, but I haven't started yet. I think I can build one in the next 48 hours. It's gonna be tough, and it's gonna be a challenge, but I think I can do it. I built one before, so let's get started. Well, I don't actually have a plan yet, so I'm gonna do a plan and I'll get back to you. In order to electrospin, we need quite a few things. First, we'll need a syringe pump, so some sort of device that slowly pushes a syringe and pushes a polymer solution out of the syringe. We'll also need a high voltage power supply. This way, we can apply high voltage charge onto the polymer solution. And as we apply high voltage charge, we're going to get this incredible charge differential between the collection plate and the tip of the polymer solution. And as the voltage increases, it will hit a certain voltage called the critical voltage, where the charges on the polymer solution become so strong that they overcome surface tension. It spontaneously emits a jet of polymer solution that flies towards the collection plate. It starts to spiral out and stretch out and form this like whirlwind whipping effect, and then it lands on the collection plate. As the polymer solution flies through the air, the fibers are stretched so thin that the solvent of the polymer solution almost instantly evaporates, leaving behind fibers that can be deposited onto the collection plate and collected for later. Okay, for the syringe pump design, I have this old design that I've been working on. It's actually on my bioprinter right now. Let's see if we can get to it. This design right here, I plan on using that design, but I plan on modifying it really quick. I want to make it much more stiff and much prettier to look at. It's pretty gnarly and pretty ugly, so I'm gonna get designing right now. Alright, I just finished updating the design of this syringe pump, and I put it into the slicer and sliced it up. Now I'm ready to pop it onto the 3D printer and let it run. I'm only going to print the main part of the syringe pump because there's a few parts where the supports look a little iffy, and I'm worried that if it fails it'll ruin the other parts. So I'm going to only print this one. It is an 8-hour print, and it should be done around 11 plus 8. Oh god, math. 7 p.m. 7 p.m. Once this one finishes printing, then I can print the other pieces. I just want to make sure this one prints well.
Take a trip down on Easy Street. That's where all of the losers meet. Alright. Bang their heads on the concrete wall for easy access to diamond holes. Alright.
While the syringe pump is 3D printing, I figured the next step is to make the polymer solution, and I think I'm going to use PCl and acetone. Last time I did electrospinning, I used PVA and water, and that's because I felt safe compared to any other polymeric solutions that you could electrospin. I think you can electrospin PCl and acetone. I'm not entirely sure. I'm going to go check that out, see if that makes sense, and then get going. Ow. That hurt.
Take a trip down on Easy Street. That's where
Alright, I think I got everything I need to get started. PCl acetone is dissolving right now. It's pretty much all dissolved. There's still some particulates in here, but I read online that is pretty common, so I think I'm going to move forward with it right now. My plan right now is to try electrospinning or electrospraying just by hand. So what I'm going to do is I'm going to fill a syringe full of the PCl solution. I'm going to attach the positive end of the high voltage power supply to a needle attached to the end of the syringe. I'm going to attach the negative end or the ground end of the high voltage power supply to a collection plate that's made of aluminum foil, and then I'm going to give it a shot. I'm just going to slowly press with my thumb and slowly increase the voltage with my other hand, and we're going to see how it goes. Oh, it's spraying. Close. Alright, so it's probably a little bit tough to see, but I just tried electrospinning some of the PCl solution that I just made. I just did by hand. I didn't use the syringe pump. That's still printing. I don't know if it was easy enough to see. It seemed that I was able to electrospray, but not electrospin. The difference between electrospraying and electrospinning is that in electrospinning, nanofibers, continuous nanofibers are formed, whereas in electrospraying, droplets are formed. So it's droplets versus fibers, and I'm looking for fibers, but electrospraying is a good step forward. So in the meantime, I'm going to try and concentrate the PCl solution. It seems like it's still a little bit too dilute in order to form continuous fibers. To concentrate the solution, I'm just going to take off the cap and heat it up and let the acetone evaporate until I get to a point where I get fibers. I don't know, we'll see.
You take a good look in the mirror. Yeah, let's not talk about it. You've got $1 million face, but you're a part of every masquerade. Don't say a word about it. You're a crazy train riding alright, but crashes near, so cover your eyes.
Woohoo! Let's go! Oh, that's so sick. But are they fibers? That is the question.
Hey girl, see your silver tongue. In every way it makes me shiver. But let's not talk about it. You've got that $1 billion smile that stays forever in my mind. Don't say a word about it.
Seems to be wisps of fibers, but nothing that looks super continuous. This big fibers from like an over extrusion. There's a lot of thin little strands, but it's hard to tell exactly what I'm looking at. Yeah, it's more like electrospraying. Alright, update time. The syringe pump is still being printed. It's nowhere near done. What am I saying? It's nowhere near done. It's gonna be done around like 7 p.m. tonight, and it's only 2 p.m. Alright, I've tried 3 different polymer solutions already. First, I did 80 mLs of acetic acid with some amount of PCl beads. I have no idea how much. I'm just reducing the amount of acetone every time until I start getting a working electrospun fiber. To do this, I'm just reducing it on a hot plate. First, I reduced it by half, and then I reduced it by another half, and now I'm on to my 4th reduction by half. So we're down to, what, the 16th? Ooh! Oh, that's exactly what I want. Oh, yeah. Oh, that's perfect. That was so perfect. Ooh, that was perfect. Please don't shock me. Don't shock me. Oh, look at it go. Look at the fibers. Yes! Oh, this is exactly what I wanted. Look at those fibers. Look at them. Look at them. Let's go. Let's go, let's go, let's go. Okay. I'm excited. I'm about to focus in on the Electrospin fibers. Oh, there they are. Look at them. Not the big ones, the really small ones in between them. Like here. Look at them all. Like, look at that. Look at that. Look at that edge right there. Oh, wow. Oh, that's so sick. Okay, sick. I think we got it. Well, maybe. Alright, this is the start of day 2. To recap what happened yesterday, we 3D printed a whole bunch of parts for the syringe pump, designed them on Rhino Grasshopper, and we also made some PCL and acetone solution. It turns out overnight it looks like some of the acetone in the PCL solution evaporated away, so it might be a bit more concentrated than it was yesterday, but that shouldn't be too much of an issue. If it is too concentrated, then I can just add some acetone to dilute it and it should be all set. And the plan for today is to set up the electronics for the syringe pump, specifically setting up the stepper motor so that it slowly extrudes polymer solution over a long period of time. Finally assemble everything and then get electrospinning. And hopefully we can do this by the end of the day. I'm pretty sure we can. Whoops, blew up a capacitor. Alright, it took me like 3 hours, but I got it working. I have a stepper motor spinning on its own. I really don't want the high voltage power supply to shock any of my equipment, so I'm having all the electronics on their own standalone platform. That way my computer and my 3D printers aren't interacting with the high voltage power supply in any way that could result in a short circuit. That's the idea. Hopefully it works. We'll see. Check it out! Check it out! Look at that! Okay, so right now I have this thing spinning pretty fast, but when we're electrospinning, it's going to be spinning at a rate. This is how fast it will run normally. This fast. Alright, I finally finished setting up the electronics. Now it's time to assemble the whole syringe pump and get into the electrospinning. Right now I'm going to assemble my 3D printed syringe pump, and then I'm going to add a stepper motor, and then I'm going to hook up all the electronics, make sure that they work, and then I'll get back to you. Stupid mistake. Okay, so I've made quite the rookie mistake. While 3D printing this piece, the syringe pump, this overhang came out with particularly bad print quality. And as a result, the flange pusher doesn't fit. Well, it fits, but the friction is so tight that it's just not going to work. I don't know if I have time to reprint one of these. I might just end up using my old syringe pump design and just attach what I have printed so far and just toss out this guy. Not much I can do right now.
watch it fading. Eventually, my heart knows no remedy. I don't know no remedy.
Okay, I finally finished assembling the electrospinner. I have the electronic setup, I have the syringe pump assembled, I have the high voltage power supply hooked up, I have the aluminum plate ready to collect. All that's left is to try. So let's give it a shot. Hopefully nothing goes wrong, hopefully I don't shock anything. Alright, let's go. It's going in reverse. I don't know how to fix this. Alright, here we go. Nuts. Ooh, that's just a sad looking image, isn't it? Alright, quick update. I just tried electrospinning for the first time. It kind of worked. It looks like the surface tension of the PCL and acetone is way too high. Fibers aren't spontaneously shooting off of the syringe, rather they're kind of staying and forming these long spindle-like. That is not what I want. I want them to spontaneously eject from the droplet itself rather than stick to it. To help remove the spindle-like fibers that I'm seeing, I'm gonna add a bit of Dawn dish soap to the PCL and acetone solution. The Dawn dish soap has soap, and soap decreases surface tension, so in theory, a little bit of extra soap should make it easier for the fibers to shoot off rather than form spindles. I just added the Dawn dish soap to the acetone, so we're gonna let it spin for the next couple hours and see where we are in a bit. Looks like the surface tension's still too high. Okay, so I'm having a little trouble actually using the syringe pump with electrospinning in tandem. Honestly, it's probably because I haven't measured anything and I don't have anything that's reproducible. So right now, the solution that I made yesterday is electrospinner-able, but the solution today evaporated more acetone and now it's too thick to electrospin. And so I'm having a lot of trouble going back and forth between too thick and too thin. There's a nice little happy spot where the electrospun fibers will actually make fibers.
There's no
Wow. It's late, but it works. Let's go! I am so happy that it's working, and only took 2 days. That's it. In the future, I want to use this for some artwork projects. I have a few things in mind that I will probably show you guys in the future, but until then, hopefully you enjoyed, and I'll see you.